All right, for the second part of lesson 2.1, and actually this should, instead of say day 2, it really should say part B. All right, so we're going to still do some work with properties of exponents, and then we're also going to extend this lesson into working with scientific notation, which you might be familiar with already, but this will be some good review with that. So you can see the 3 objectives here, and let's go ahead and do some recall of what we learned in our last video. We are going to simplify each expression using the properties of exponents, and we want to tell which property is used as you go ahead and simplify. There should be no negative exponents in your final answers. So if we take a look at the first one, we notice that there's a -3 as an exponent outside the parentheses, so we need to apply that or distribute it to each thing inside the parentheses. There's a 3 that needs that -3 distributed to it. There's an a to the third, and we need to multiply those two exponents together. So the 3 and the -3, that makes that a -9. And then b to the 5th times the -3 as the exponent, so 5 times -3 is going to be -15. Now, when we see that we have distributed that, we call that the power of a power rule. And then what do we call it when we have the negative exponents, and what do we need to do with them? Well, we know that we need to move everything to the basement, so we're going to put 1 on the top as our numerator, and we're going to simplify the 3 to the -3rd. That's going to be 3 to the 3rd. And then we also have a to the 9th. Remember, it becomes positive as we bring it to the basement, or the denominator. The technical term is denominator. And then, of course, the 15 is going to be positive for that b part. Now, we do want to simplify 3 to the 3rd. 3 times 3 times 3 is 27. So I'm going to put my final answer here, 1 over 27 times a to the 9th, b to the 15th. Okay, and we did have this on a previous exercise, so you should be familiar with that specific problem. All right, let's take a look at problem B. I would like to separate this out a little bit. I'm going to separate this by putting the 4 and the r to the 4th and s to the 5th over, kind of separate them out a little bit, even though we're still multiplying all of those things. And then the 24 r to the 4th, s to the -5. Again, this is a problem that you probably are familiar with because we did it on another worksheet. But what I would like to do is show you that there are 3 things that you can simplify. You can simplify the numbers, you can simplify these things here because they both have r's as their base, and then you can simplify the s's because those both have s as the base there. So one of the things that we're going to do is we're going to reduce 4 over 24, and that's going to be 1 over 6. That's the reduced fraction of 4/24. Now, we all know that anything over itself, so something over itself, is just going to turn into 1. There's another way to look at that. R to the 4 minus 4 power, because we're subtracting these exponents when we have a division problem, that's just going to be r to the 0, which is also 1. Anything to the 0 power is going to be 1. So we could say that that is 1. And then, of course, the s situation there, s to the 5th power minus -5. When we have minus negative, that becomes plus, so that's going to end up being s to the 10th. So we're going to have an s to the 10th here. And to really simplify everything down, and I didn't write the rules in there, I don't really have space. The final answer for this problem is going to be s to the 10th over 6. We don't need the 2 number 1s at the top there. So that's my final answer. Now, a couple things that we did. We used the quotient of powers. So quotient of powers, that's when we're subtracting the exponents. And then we use the 0 exponent here. And I think that's pretty much it. That's all we used. Then, of course, we just reduced the 4 over 24. So that's just a review of what we did in our last video. So let's go ahead and take a look at the new information for this lesson, scientific notation. And let's just read what we have here. Sometimes it saves time to abbreviate words. For example, instead of writing out the word example, we can just write EX period, or instead of writing laugh out loud, we can write LOL. Can you think of some common abbreviations for words? Of course you can. So we're going to learn how to abbreviate a scientific, or use scientific notation, which is actually just an abbreviation of numbers. So just as often we seek to have time saved by abbreviating words, the same can be done for numbers, and we are going to be able to shorten or abbreviate this number, and that's going to be called scientific notation. So the definition of scientific notation is when we take a number in this form, and this is kind of a technical definition. We're going to have a number times 10 to a power. Okay, so the n there is a power or an exponent, which is why we're going to include it in this lesson, because we're dealing with exponents right now in our class. So, and that's where C, the number C, has to be between 1 and 10. Okay, so the absolute value of C has to be somewhere either equal to 1, greater than 1, but it has to be less than 10. It cannot be greater than 10. So just a reminder, these lines here indicate absolute value, so even if C is negative, it's okay because we're taking the absolute value of it, and that gets rid of that negative sign. And the other thing that we want to make sure of when we're writing this in scientific notation is n, the exponent, is non-decimal. It cannot be a decimal. And in that case, it would not be able to be fractional either. So let's take a look at the example problem that we have. It looks like this large number can be condensed down and abbreviated to 1.546 times 10 to the 12th power. Well, why is that? First of all, let's identify this right here is C. Okay, like we said, C has to be between positive 1 and 10. So that number is between 1 and 10. And then we have a multiplication symbol. And then we have 10 to some power. Well, where did this power come from? How do we know that it's got to be 12? The reason that it's 12 is because it's the number of times the decimal place is moved in the original number. So if I have a decimal place at the end of this number and I move it, I've moved it so that I get a number that is between 1 and 10. Now, how many times did I do that? Obviously, I've done it 10 times because, or sorry, 12 times. That's because my exponent here is 12. So the exponent, so n, let's say, equals the number of times the decimal is moved until we arrive at a number between 1 and 10. All right, let's take a look at some example problems on the next page. Here we have the step-by-step instructions on how to write a number in scientific notation. So first of all, locate where the decimal place currently is in the number. So it looks like I have the decimal place down here at the end. Anytime we don't have one in the number, we place it to the far right. And as we showed on the first page, we're going to move that decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times until we reach this point right here. Because I need to have a number somewhere between 1 and 10, that's the rule to set this up. So I'm going to move my decimal place over 12 times. And that's the second step, is the moving of the decimal place, either left or right, until you can create a number somewhere between 1 and 10. So we moved it over 12 times, and that means that we have an answer of 1.546. Remember, we moved that decimal place over to here, and that's going to be times 10 to the 12th power. All right, step 3, it says write the number in scientific notation with the exponent equaling the number of times you move the decimal place in step 2, and we did that. Your exponent will be negative if the absolute value of the original number was between 0 and 1, and the exponent will be positive if the absolute value of the original number was greater than 1. Okay, so let's take a look at the next example, because this one's going to end up being a negative exponent. So if we look at this number right here, it says locate where the decimal is currently. Well, this number, because the decimal is on the left, we know that we're going to end up with a negative exponent, because when we move our decimal to the right, we are going to, not because we're moving it to the right, because our original number began somewhere between 0 and 1. This number is not larger than 1. So let's go ahead and move our decimal. 1, 2, 3, 4, 5, 6, 7. Okay, so we've moved our decimal place over 7 places, and now we have 8.6. Okay, the original number though was between 0 and 1, and that means we're going to have to say that this is going to be a negative number, and we moved it over 7, so our exponent is negative 7. Alright, so example 2 says to write each number using scientific notation, and I am going to do A, B, and C, and then I'm going to ask you guys to finish up D, E, F, and G. If you take a look at G right now, there's a lot of places that you're going to have to move that decimal over, and so don't be afraid. It really is kind of just a silly, mass of an electron. And that's not silly at all. It's just that we're trying to make a point here is, make sure you count carefully. So writing each number, remember we have to first locate the decimal. Where's the decimal? My decimal is all the way over here to the right. I'm going to move my decimal over. Here's 3, 6, 9, 12, and I'm going to move it 13 places. I just counted by threes to make it easy. So my number is 1.5345 417. Okay, and then because I start the zeros there, I'm going to say times 10 to the 13th power, because I moved my decimal over 13 times. And I know that it's positive because my number when I started was greater than 1. All right, so B is a little bit different. Notice that the decimal is over here, which means my original number is between 0 and 1, so therefore I'm going to have a negative exponent. So let's go ahead and write that in right now. 10 to the negative, we don't know what yet, but we're going to have a number here in just a second. So I'm going to move my decimal over. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've got to move it over 8 places so that I have 9.8756, and my exponent is 8 because I moved my decimal over 8 places. All right, so there's my answer for that one. Now this is a negative number, but that's okay because we know that we can take the absolute value of any number and that's going to make it positive. So don't let this negative number scare you, or its negative sign scare you. Remember, to begin with, you want to begin by noticing where your decimal place is. It's all the way over here at the right, and then go ahead and move your decimal. 3, 6, 9, 12, 13 again. And even though the negative sign is there, we're going to keep that negative sign. It's going to be 1.1, negative 1.1 times 10 to the 13th power because I moved it over 13 times. Okay, with D, E, F, and G, would you please make sure that when you give your answer, you have the units that they're asking you about. Okay, so the D, F, and G actually have units: kilograms, kilometers per hour. There won't be any units for E, but practice these, try out the steps, go back if you need to, watch the video, rewind it a little bit if you need to. Okay, on the last page of our notes, we have some examples here that are a little bit more challenging, take a little bit more thought, and so we have some new steps that we want to go through here. Notice what we're doing is we're multiplying some scientific notation numbers together. So it says for step 1, rearrange the terms so that the bases of 10 are next to each other. So let's go ahead and do that. So it's going to be 10 to the 7th times 10 to the 3rd. Okay, then we're going to put that next to each other. And then we're going to have 8.5 times 1.2. So all I did is I rearranged. I put this here, and I put the 10 to the 7th with the 10 to the 3rd. Now what can we do with this? Well, because the base is the same, we can use our product of powers property. So in step 2, it says multiply the numbers without the exponents. So we're going to multiply 8.5 times 1.2, and I get 10.2 when I do that in my calculator. And then it says to use the product of powers property to multiply the bases of 10. So I'm going to say 10 to the 7 plus 3. Remember, 7 plus 3 because we can add those exponents together. All right, and if I follow the next step, well, let me just finish this here. 10.2 times 10 to the 10th. Okay, now if you did 10 to the 10th on your calculator, you get a really big number. So let's just take a look at what they want us to do here for step 3. Move the decimal place to create a number between 1 and 10. Well, we don't have a number between 1 and 10 right now, do we? It's actually bigger than 10. So I need to move my decimal place over 1 time. Now, add the number of times you move the decimal place to the exponent. So if I moved 1, then I add 1 to the exponent. So add 1 to exponent, and that's this exponent we're talking about. All right, so my final answer for this is going to be 1.02 times 10 to the 11th power because I added 1 to 10. Now I just noticed that I made an error here, so let me just cross that out. You guys can go ahead and erase yours. 1.02 should be my answer here. Once I moved this decimal over, I definitely should have changed that, so I apologize for that error. All right, so example number 4 is asking us to divide. Okay, so we're going to do something pretty similar as we did just now. Right now, though, we already have this set up. It says step 1, divide the numbers without exponents, and then use the quotient of powers property. Notice that the 10 to the 7th and 10 to the 3rd is already set up, so we really don't need to rearrange any terms, do we? All right, so that's already set up, and it says divide the numbers without the exponents. All right, so 8.5 divided by 1.2, that's going to be 7.083. And then it says that we want to use the quotient of powers property to divide the bases of 10. So that's just going to be 10 to the 7 minus 3, or I could rewrite this as 10 to the 4th power. Remember, we can subtract those. So this is what I end up with. Now let's just make sure one more thing. Move the decimal place to create a number between 1 and 10. Well, this number is already between 1 and 10, so we really don't have to do anything with that. And if we did, if the number was not between 1 and 10, we would add the number of times you move the decimal place to this exponent right here. Okay, so we're all set. Our answer is complete. So what I would like you to do is try the ones here at the bottom of the page. Go ahead and rewind this video if you had trouble the first time. It does look like we have actually two that you're going to do multiplication with, and two that you're going to do division with. So be really careful with that. Make sure that you have things set up properly before you start using the powers rules, and also make sure you add another number to your exponent based on the number of times you move that decimal. This is a -7 in the exponent here, and this is a -3 in this exponent here. This is a -3. These are really tiny, so I just want to make sure this is a -8 in that exponent there, and that's a -4 exponent in that one. So be careful. Of course, if you have questions, we'll answer those in class. Good luck with on your own problems.